students, so today we will learn how to find displacement in the nth second. We've studied distance, displacement, we know acceleration, we know all the formulas and how to calculate all of them. We saw certain numericals also. So let's proceed and let's learn how to find displacement in the nth second. Remember children, whenever we want to find direction of motion, for direction of motion, if distance or displacement is given, it is never enough. You have to find velocity. If velocity is positive or greater than 0, that means the displacement is in the positive direction, or direction of motion is in the positive direction. Okay, like if I say displacement of a body is 10 meter, or if I say displacement of a body is minus 10 meter. Minus 10 meter displacement doesn't mean that the body is away from, like if this is the 0 origin. You might think that displacement is 10 meter is towards the positive acceleration of 0 and minus 10 meter is like this. No, this knowledge doesn't tell you whether the body is moving backwards or forwards. For that you need the idea of velocity. Okay, and remember one more thing, that all the three equations of motions which we have studied, v is equals to u plus at, s is equals to ut plus half at square, and v square minus u square equals to 2as. In all these equations, this s represents displacement, not distance. Okay, remember, though we denote distance also with s and displacement also with s, but in the three equations of motions, these acceleration is constant acceleration and s is displacement, not distance covered. Okay, we'll see certain numericals also to prove this. Today we are studying how to find displacement in the nth second. So for example, the body started from the origin, okay, and you have to find the displacement in the third second, for example. Okay, displacement in exactly the third second. So we always measure displacement like, you know, displacement of the body in 3 seconds. How much is the displacement of the body in 3 seconds? Okay, this total body reaches from O to A in 3 seconds. Okay, and if you know the displacement of the body in 2 seconds, for example, in 2 seconds the body reaches B. Okay, the body reached B in 2 seconds, and in 3 seconds it reached A. So how to find this displacement, which is the displacement in the third second, after the second ended and before the third second ended, that is the displacement in the third second. So this you can find out if you know displacement in 3 seconds, that is OA. Okay, and if you know displacement in the 2 seconds, that is OB. So the displacement in the third second can be found out by OA minus OB. This will give you this displacement in the third second. Okay, so what is OA? This is displacement in 3 seconds and OB is displacement in 2 seconds. So displacement in the third second formula we got like this. So you can write displacement in the 5th second. 5th, not in 5 seconds total. Only in the 5th second. Displacement in the 5th second will be displacement in 5 seconds minus displacement in 4 seconds. Okay, like that you have to find. Similarly, if you want to find displacement in the first second, that will be displacement in 1 second minus displacement in the 0th second. Okay, displacement in 7th second will be 7 seconds displacement minus 6 second displacement. Okay, so this is how you can find displacement in a particular second. Okay, displacement in nth second, right? So one more thing, remember, before we take the examples on this topic, remember that if you have like velocity, and if you have to find acceleration, then we know A is equals to dv by dt. If velocity is given to you, some velocity is given, you can differentiate it and find acceleration. What if acceleration is given and velocity is asked? Then what do you do? Take this up. A dt is equals to dv. Integrating both sides, integration of a dt is integration of dv. Integration of dv will give you v is integration of a dt. So remember this formula. If you have acceleration and you want velocity, then you can integrate a dt to get velocity. Similarly, we have velocity is equals to ds by dt. If displacement is given to you, you can differentiate it and find velocity. If displacement is asked and velocity is given, then the same thing, v dt is equals to ds, or integration of ds is equals to integration of v dt. Integration of ds will be the displacement, integration of v dt will give you displacement. Now this integration sign can be definite integration or indefinite integration. Definite integration means if I ask you, if I give you velocity and I ask you displacement from 0 to 2 seconds. So from 0 to 2 you will integrate this v dt. So this is a definite integration. You know the limits of the integration. If directly velocity is given and the question is asked, and between from where to where is not given, okay, then that becomes indefinite integration. So you just integrate v dt, and whatever answer you get, the plus c sign will come. That means a constant will come for indefinite integration. Okay, then some condition will be given in the question for you to find the value of c. So first we find the value of c, put it up, and then we proceed with the question. Let's see some numericals. For example, the question is, if v is equals to t plus 1, find s from 0 to 4 seconds. Also find s at the end of 4 seconds if initially body is at origin. So this is the second part. Okay, and this is the first part of the question. So firstly, we have been given v is equals to t plus 1, and we have to find s from 0 to 2 seconds. So we know s is equals to integration of v dt from 0 to 2. So since the limits are given, so this is a definite integration like I was telling you. So s will be integration of from 0 to 2, v is equals to t plus 1 dt. Okay, now integration of t plus 1, you can integrate both of them separately. Integration of t will be equals to t square by 2, n raised to the power n plus 1 by n plus 1, plus integration of 1 dt will be equals to t. Okay, so this is from 0 to 2. Since it is definite, so we don't need to add c. Now putting the limits in place of t, 2 square by 2 plus 2 minus 0, 0, 0. Okay, so that will be equals to, so your s is equals to 2 square, that is 4 by 2, 4 by 2 will be 2, 2 plus 2, that is 4 minus 0. So s is equals to 4 meter. Okay, so from 0 to 2 seconds, when the body moves with this velocity, the displacement is 4 meter. Coming to the second part, if at the end of 4 seconds, find displacement at the end of 4 seconds if initially body is at origin. Okay, so initially body is at origin, that means when time is 0, body is at origin, that means displacement is 0. This is the condition given. And you have to find displacement at end of 4 seconds. So again, displacement is equals to integration of v dt. Since now here no limits are given, so this will be an indefinite integration. So that will be equals to t square by 2 plus t plus c. Okay, now you got the difference. So here we have the equation of s. Now at the end of 4 seconds we can find by applying t is equals to 4 over here, but we need to know the value of c to get the exact value of s. Okay, so what do? We apply this condition. When t is equals to 0, s is equals to 0. So 0 is equals to, this is 0 plus c. That means c is equals to 0. We get the value of c. Now putting c equals to 0 over here, we are left with s is equals to t square by 2 plus t plus 0. Okay. So at the end of 4 seconds, s4 will be equals to 4 square by 2 plus 4. So that will be equals to 16 by 2 plus 4, that is 8 plus 4, that is 12 meter. Okay. So displacement at the end of 4 seconds is 12 meter. So this is how you can solve any question. With the knowledge of velocity, you can find displacement. Let's practice one more question. If v is equals to 2t, find s at t is equals to 3 seconds. The body is 2 meter behind origin and t equals to 0. That means in the beginning, the body is 2 meter behind the origin. This is the condition given, and you have to find s at t is equals to 3 seconds. So we know v is given, s is equals to integration of v dt. Since limits are not given, so this will be a definite integration. So s will be equals to integration of 2t dt. Okay, so integration of 2t will be 2t square by 2 plus c. Okay, so that will be equals to t square plus c. This is s. Now applying the condition to find out the value of c, we know at t is equals to 0, s is equals to minus 2 meter. 2 meter behind. Behind, that means s will be equals to minus 2. So minus 2 is equals to t square plus c. Okay. So minus 2 is equals to 0 plus c, or c is equals to minus 2. C is equals to minus 2. So we got the value of c. Now we can find s at t is equals to 3 seconds. That will be equals to 3 square plus c. That will be 3 square minus 2. C is value minus 2. So 3 square minus 2, that will be equals to 9 minus 2, that will be equals to 7 meter. So displacement at 3 seconds, at the end of 3 seconds or in 3 seconds is 7 meter. Right? So if acceleration now is given as 3t square, find velocity at t is equals to 3 seconds if initially body is at rest. So now velocity, you have to find an acceleration is given. So velocity is equals to integration of a dt. Right? So v will be equals to integration of 3t square dt. Since no limits are given, so again this will be indefinite integration. So 3t cubed by 3 plus c. Okay. So 3 will get cancelled. Velocity is t cubed plus c. Now to find the value of c, if initially body is at rest. So at t is equals to 0, body is at rest. That means its velocity will be 0. So 0 is equals to 0 plus c. That means c is equals to 0. So applying v is equals to t cube plus 0. At t is equals to 3 seconds. So v will be equals to 3 cube. That will be equals to 3 cube. That will be equals to 27 meter per second. Okay. Right. This question, first question is for your homework. Please note it down. If a equals to t square plus t plus 1, find velocity at t equals to 2 seconds. If at t equals to 1 second, body is moving with velocity 2 meter per second in negative x direction. Okay. So please note this question down. It is like the previous one. Acceleration is given, and you have to find velocity at t equals to 2 seconds, and a condition is given. So please do it in your copies and find the solution. The next question is, if a equals to x square, find velocity when x equals to 2 meter. Given at x equals to 0, body is at rest. So So see here, velocity has to be found, but displacement is not given. Acceleration is given, that too in terms of x displacement. So here we have to find, we know A is equals to v dt, right? We know this formula, acceleration is v dt. There's one more formula for acceleration, that is we can write, we know v is equals to dx by dt, right? You know velocity is ds by dt or dy by dt. Since x is given over here for displacement, we can write v is equals to dx by dt. Right? Now we can write a is equals to v dt. A is equals to, or you know that acceleration is given by dv by dt. Simply, let's make it simple. You know acceleration is rate of change of velocity. Okay, multiply both sides, multiply and divide both sides by dx dx. So that can be, now you can club dx by dt and you can write dv by dx into dx by dt. Right? Now what is dx by dt? You know dx by dt is velocity. V is equals to dx by dt. So substituting this as v dv by dx. Okay? So v dv by dx is acceleration. This is also one more formula for acceleration which you have to remember. I have discussed this in the previous videos also. I am repeating was important. A is equals to v dv by dx. Now taking dx on this side, a dx is equals to v dv, or I can write it v dv is equals to a dx. Okay, now integrating both sides, integration of v dv is equals to integration of a dx. Why we did all this? Because our acceleration is given in terms of x. Okay, if acceleration would have been given with velocity directly, a is equals to dv by dt we would have done. Okay, or v is equals to integration of a dt you could have done. But acceleration is given in terms of displacement, so you have to express acceleration in terms of displacement, and acceleration then will be integrated with respect to dx. Okay, so integration of v dv will be equals to v square by 2. Okay, v square by 2 is equals to integration of a dx. Integration of a is x square dx. Okay, so v square by 2 is equals to integration of x square is x cube by 3 plus c. Why plus c? Because again it is an indefinite integration, right? So we can write v square by 2. Now you have to apply the condition given at x equals to 0, body is at rest. If body is at rest at x equals to 0, that means when you substitute x equals to 0, velocity will also be 0. So here 0 is equals to, you can write at x is equals to 0, body is at rest, velocity is 0. So 0 is equals to 0 plus c, right? V is 0, velocity is 0, x is equals to 0 plus c. So c becomes 0, right? So you have v square by 2 is equals to x cube by 3. Now you have to find velocity at x is equals to 2. So substitute x is equals to 2, v square by 2 is equals to 2 cube by 3. Okay, when you take this 2 up, it will become 2 cube into 2, that is 2 to the power 4. V square is equals to 2 to the power 4 by 3, right? So v will be equals to under root of 2 to the power 4 by 3. That will be equals to square root of 2 to the power 4 will be 2 square will come outside. 2 square by root 3. This will be plus minus because you don't know whether it is positive or negative. Roots can be both positive as well as negative. So 2 plus minus 2 2 square, that is 4 by root 3, is the velocity when x equals to 2 meter. Okay. So I think we've done enough examples for finding acceleration. If velocity is given, acceleration if displacement is given, velocity if displacement is given, displacement if velocity is given, and all those. So in the next class we'll start with equations of motion, their derivations we'll do, and then we'll see some numericals. By the time, please do the homework. Thank you.